In this video, we're going to work through some examples using the plane or using planes, and the key idea with all this stuff is to set up a good picture. And honestly, it might take some while or some time to properly visualize the problem. Okay, so expect to spend a little bit of time working with the information, take a shot at it, and if it doesn't work out right away, keep trying, and really just persevere. So in this example, we have triangle PAB and square ABCD. Okay, so we're given that PA, and I'm just going to start labeling this stuff. So PA is equal to 3, so this is 3, and PB is equal to 4, and AB is equal to 5. Okay, and this is a square, so all the sides are the same. And we also know that these are perpendicular planes. So if I make a little 90-degree angle here, it is that it's just representing that these two planes are perpendicular. So what it's asking me to find is the length of PD. Okay, so I'm going to draw this in here. Okay, and so just finishing labeling this 5, 5, 5. What I'm seeing is that if I look at PAD, those all lie on the same plane. Okay, so again, 3 non-linear points determine a plane. So really, if I look at this now, instead of in 3 dimensions, if I look at it in 2 dimensions, which is a very, very, very important skill in solving most of these problems, I would see that I'd actually have something that looks like this. Well, straight lines. Okay, and I'd have D up here, A, and P, and I would know that since these are perpendicular planes, this is a right angle. I know that PA is 3, AD is 5, and then PD, well, that I can get using the Pythagorean theorem. So this is going to be the square root of 9 plus 25, or just the square root of 34. Okay, so just to recap, what I did is I put in all my information. Okay, and then I looked at what I needed. I looked at PD, and from the diagram, I saw that, well, PAD all lie on the same plane, and that plane, when I look at it, the two-dimensional figure that I get out is a right triangle, and it's right because the planes are perpendicular. And then I'd use the Pythagorean theorem to find this missing side. Now in this problem, they actually gave us more information than we need. They gave us that PB is 4, and we didn't really use that in the problem, so also be aware of that. They may give you more information than we need sometimes. In example 2 here, this really is more of a, I wouldn't say a proof type problem, but this is more of a reasoning. So in addition to our solution here, if we determine yes or no, we need to explain why or why not. Alright, so looking at this one, so we're given a plane P, so I'm going to draw that. So here's my lovely plane. Okay, best as I can draw, here's plane P. Okay, and given a plane P in space and a point X not on the plane, so I'll say here's point X, is the nearest point on P given by the foot of the perpendicular segment from X to plane P. Now, logically, we know that, okay, well, shortest distance is given by a line, okay, and shortest distance is probably a perpendicular line, but let's actually check here. So, and I think our skill, our knowledge of triangles is going to come in to help us here. Alright, so what I'm going to do is I'm going to consider 2 points. I'm going to consider a point, let's call this Y, and let's consider another point, say Z. Okay, now I've constructed Y such that if I look at the distance from X to Y, this is going to be the foot. Okay, so the foot is just the base of the right angle, and so now I consider that distance. I call that d1. Okay, and then z is any other point on the plane. I want to compare those two. See how the distances compare. And so I draw a line also to x, and call this distance d2. Okay, and they're separated by some other distance. I don't know what to call that. Let's just call that k. So what I'm saying, I want to look at and try to determine a relationship between d1 and d2. See which one's bigger. Well, fortunately for me, this is a right triangle, and almost by inspection, I can say, okay, well, since it's a right triangle, d2 is the hypotenuse, and so then d1 is going to be less than d2, and really I think that's enough justification here. But if you want, you can also set up the Pythagorean theorem. So d2 squared is equal to x squared plus d1 squared. And sorry, this isn't x, this is k. I need my eraser. This is k. And so then I can just look at how this would compare, say, to d1. And, well, since d1 is used in the equation, we already have to square it. So I can say that this implies that d2 is greater than d1. So d1 would be the shortest distance. So my conclusion to this would be, and I'm not going to write it out, but I'll just kind of talk through it. So is the nearest point on P given by the foot of the segment from X to plane P? Yes. And then our reasoning would be, let Z be another point on plane P. Then we can construct these lines, and then by the Pythagorean theorem, it shows that the distance from x to that other point is greater than the distance from x to that foot, and then that's enough justification for this problem.